In this lesson, we'll learn how to calculate present value when compounding continuously versus daily. So you'll see the difference between the two. Remember, when we're looking at compounding continuously, we use the base E, Euler's number, which is approximately 2.71. Whereas when we're compounding daily or monthly, whatever the case may be, you use the compound interest formula, and that's what dictates the base found in the exponential model. The question reads, find the present value of 18,000 if interest is paid at a rate of 8% compounded continuously for 20 years. Compare this amount to the same investment that was compounded daily. So pretend that you have a mortgage or a loan that you have to pay off, and it's $18,000, and you have agreed to 8% continuously for 20 years. For this, we'll use the exponential growth formula, and that's found right here. The amount that we owe is 18,000. So I'll set that as A. 18,000 is equal to P times E raised to the power of RT. R is the interest rate per year. In our case, it's 0.08. Make sure that you convert 8% as a decimal. Multiply to the amount of time, which is 20 years. We need to find out what P is. And that's not a problem. To do that, we can divide both sides by this factor. So if I divide both sides by e to the power of 0.08 times 20, we should end up with P. Let me show you what that looks like. 18,000 over e to the power of 0.08 times 20. Now what's interesting is that depending on the level that you're learning this, they might just give you exponential growth and exponential decay formula. Exponential decay is when you have PE raised to the power of negative RT. And the reason why they have negative RT for exponential decay is because you can rewrite this algebraically as 18,000 e to the power of negative 0.08 times 20. Now you can see the relationship between the two formulas. So let's go ahead and compute either of these because either of them will give you P. I'll use the one on the left. 18,000 divided by E raised to the power of 0.08 times 20. Okay, we end up with a principal of 3,634. This is how much is left of the 18,000 after 20 years at this rate. So 3634.14. I'm rounding to the nearest cent, which means 2 decimal places, and that's our amount. So if we do this again for compounding something daily, we use the compound interest formula. Once again, we are looking for P, and we have every other value. So I have 18,000 for my A. P will be left blank. 1 plus R, which is the interest rate per year, 0.08 over N. This is the new part. Number of compounding periods, 365 days. It's daily. We raise that to 365 times T, which is the number of years, and that's 20 years. Okay, so I will find out what that is and then divide both sides by it. I have 1 plus bracket 0.08, and you'll notice that I like to do things all in one step because it reduces the chances of rounding something incorrectly in the process. So I'm finding out what that is, and it equals to 4.95. I'll take 18,000 and divide it by that number. And we get 3,634. 3,634.77. Notice the difference between the two. It's a small, subtle difference. It's a subtle difference. 14 cents versus 77 cents. This means that if something is compounded continuously, obviously you get to finish the payment faster than if it were to be compounded daily. And mind you, compounding something daily makes payments go faster. So even though this is quite fast, continuous is even better. So now you know the difference between present value when compounding something continuously versus daily.